In this video, we're learning how to simplify square roots. So we're learning how to simplify roots when the number under the square root isn't a perfect square, so it doesn't come out as a nice whole number when we take the square root. So at the top of our screen, it says to simplify a square root, break down the number under the root into two factors, one of which is a perfect square. And then we've got some examples of perfect squares. So we've got 1, 4, 9, 16, all the perfect squares up to 100, and there are an infinite number of perfect squares because they just come from any whole number squared. So for the purpose of these problems, we don't actually care about 1 being a perfect square. It's not going to help us, so I'm just going to cross that out on our list. And let's jump into number 1, and I'll explain to you guys how to use this rule. So if we look at number 1, we have the square root of 8, which again does not come out as a nice whole number. There's no whole number that when squared equals 8. So we want to simplify this. So what we want to do is think of factor pairs of 8 where one of the factors is on our perfect square list. So if we think about it, 8 is the same as 4 times 2. So we're going to write the square root of 8 as a square root of 4 times 2. And now using the properties of square roots, we can change this to the square root of 4 times the square root of 2. And now the reason we chose a perfect square factor is because we can simplify the square root of 4 because it comes out as a nice whole number. So the square root of 4 is equal to 2. So we really have 2 times the square root of 2, which we can just write as 2 root 2. If we take a look at number 2, we have the square root of 32. So we want to think, what are some factor pairs of 32 where 1 is a perfect square? So we could break this up into 16 times 2, because 16 is a perfect square. And now, remember, we can write that as the square root of 16 times the square root of 2. And because 16 is a perfect square, we can simplify the square root of 16, which is 4. So we get 4 times the square root of 2, which is just 4 root 2. Now I want to show you guys that there's another way to simplify the square root of 32. So some of you may have been thinking that the square root of 32 is equal to the square root of 4 times 8. And 4 is a perfect square, so it fits with the method that we're using. So let me show you guys how to simplify it this way. So we're going to change this to the square root of 4 times the square root of 8. And the square root of 4 is just 2, so we get 2 times the square root of 8. Now you guys may notice that we simplified the square root of 8 in number 1, so we must be able to simplify it more here. So because there's another perfect square that goes into 8 evenly, right, 4 goes in, we can further simplify this root. So we can break this up into 2 times the square root of 4 times 2. And then down here, we can rewrite that as 2 times the square root of 4 times the square root of 2. And the square root of 4 is just 2, so we really have 2 times the square root of 2. And if we multiply the 2's on the outside, we get the same thing that we got using the other method, so we get 4 times the square root of 2. So it doesn't matter if you choose the largest perfect square factor of the number or a different perfect square factor, you can still get to the answer, but it is a little bit faster to choose the largest perfect square factor of the number under the root. So let's move on to number 3, which is the square root of 500. So if we think about perfect square factors of 500, we should get that the square root of 500 is equal to 100 times 5, which is equal to the square root of 100 times the square root of 5. And now because 100 is a perfect square, we can simplify it. The square root of 100 is 10, so we get 10 times the square root of 5, which is just the same as 10 root 5. And example 4 is the square root of 45. So again, take a second and think about the factor pairs of 45 and see if you could find one that has a perfect square. So 45 can be broken down into 9 times 5, and 9 is a perfect square. So we're going to rewrite this as the square root of 9 times the square root of 5. And the square root of 9 is just 3. So we get 3 times the square root of 5. And this is just the same as 3 root 5. So now we're going to take a look at some examples where we have a number in front of our root. So if we look at example 5, we have 4 times the square root of 72. So this time we have a number being multiplied by our root, but we're still going to use the same method that we were using before. So we're going to keep this 4 on the outside, and we need to think of 2 factors of 72, one of which is a perfect square. So I'm going to do 36 and 2 because I like to do the biggest perfect square that I can. You could also do 9 and 8. So I'm going to rewrite this as 4 times the square root of 36 times 2. And now I'm going to break this up into 4 times the square root of 36 times the square root of 2. And because 36 is a perfect square, I can simplify it. The square root of 36 is 6. So I have 4 times 6 times the square root of 2. And now I can multiply the numbers on the outside. So 4 times 6 is 24. And this is multiplied by root 2. So we get 24 root 2. Moving on to example 6. We have negative 3 times the square root of 175. So again, keep the negative 3 on the outside and take a second and think of factor pairs of 175 where 1 is a perfect square. So if you think about it, hopefully you get that 25 goes into 175 7 times, so we can break this up into 25 times 7. And then we can rewrite it as negative 3 times the square root of 25 times the square root of 7. Because 25 is a perfect square, we can simplify it. And the square root of 25 is 5. So we have negative 3 times 5 times the square root of 7. And finally, multiply the two numbers on the outside. Negative 3 times 5 is negative 15. So we get negative 15 root 7. Let's take a look at example 7, which is 10 times the square root of 98. So if we think about some factor pairs of 98, we should find that we can break it up into the square root of 49 times 2 because 49 is a perfect square. So we're going to write this as 10 times the square root of 49 times the square root of 2. And now the square root of 49 is 7. So we have 10 times 7, and we can't simplify the square root of 2, so we keep it as is. Finally, 10 times 7 is 70, so we get 70 times the square root of 2. Taking a look at the last example, we have negative 2 times the square root of 48. So take a second and see if you can find a factor pair of 48 where one of the factors is a perfect square. So you may have got 4 and 12, but we could also do 16 and 3, which is going to make it a little bit faster to solve the problem. So I'm going to break up 48 into 16 times 3, and then rewrite this as negative 2 times the square root of 16 times the square root of 3. And because 16 is a perfect square, I can simplify it. The square root of 16 is 4. So I have negative 2 times 4 times the square root of 3. And negative 2 times 4 is negative 8. Whoops. So we get negative 8 times the square root of 3 as our answer. Let's go through 4 more problems just to make sure we've got this down. So for these last 4 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure that you've done them correctly. So example 9 is the square root of 300. So if we think about factor pairs of 300, we can get that 300 is the same as 100 times 3, and 100 is a perfect square. So now we can rewrite this as the square root of 100 times the square root of 3. Because 100 is a perfect square, we can simplify it. So the square root of 100 is 10. So we get 10 times root 3, which we can just write as 10 root 3. Taking a look at number 10, we have 7 times the square root of 44. So we're going to keep the 7 on the outside, and we need to think of a factor pair of 44 where one of the numbers is a perfect square, and the only one is 4 and 11. So we're going to rewrite this as 7 times the square root of 4 times the square root of 11. And now because 4 is a perfect square, we can simplify it. The square root of 4 is 2. So we get 7 times 2 times the square root of 11. And finally, multiply 7 by 2 on the outside to get a 14. So we have 14 root 11. Moving on to example 11, we have the square root of 128. So if we think about some factor pairs of 128 where one of them is a perfect square, the biggest one is going to be 64 times 2 because 64 is a perfect square. We're going to change this to the square root of 64 times the square root of 2. And the square root of 64 is 8. So we get 8 times the square root of 2, which is just 8 root 2. And finally, taking a look at example 12, we have negative 8 times the square root of 63. So we're going to keep the negative 8 on the outside. We want to break up the square root of 63 into two factors where one's a perfect square. And the only ones we can do are 9 and 7. We're going to rewrite this as negative 8 times the square root of 9 times the square root of 7. Because 9 is a perfect square, we can simplify it. The square root of 9 is 3. So we get negative 8 times 3 times the square root of 7. Finally, negative 8 times 3 is negative 24. So we get negative 24 root 7 as our answer. So hopefully that video helped you guys learn how to simplify square roots. You just have to remember that you want to break down the number under the root into two factors, one of which is a perfect square. Then you're going to simplify the perfect square, and then just double check that you can't further simplify the problem.